Hello everyone, welcome to another video of the data science series. In today's video, we are going to discuss what is data dimension reduction. Now, what do we mean by dimension reduction? Dimension reduction is a technique used in data analysis to reduce the number of variables under consideration. Means this will reduce the number of values which will be considering in a regression model. For example, linear regression. If a value is 2.23 and another value is 3.0, we will be removing 3.0 so we can reduce the uh, computational cost and mitigating issue. The goal is to retain as much information as possible while reducing the number of dimensions. Let's see. Now there is a type called identify multicollinearity. Collinearity. The multicollinearity occurs when two or more predictor variable in regression model are highly correlated. For example, 2.229 is very much related to 2.230. So we will be isolating any one of them which will greatly reduce size. This can lead to and also this can lead to unreliable estimation regression coefficients. Now, what is principal component analysis? We will be further discussing in this in code example of Python. Now, principal component analysis of PCA is a dimension reduction technique that transforms the original variable into new set of uncorrelated variables called principal components. The principal components are the uncorrelated variables. These components capture maximum variance in the data, means it will be including all the variances and also excluding the recurring variances to avoid uh, space memory overuse of memory space, and which will result in smaller data set or data frame. Let's take a look at the code example. Okay, so as you can see in the code, we have imported pandas and numpy library and a states model, tools and edge constant. Okay, we have sample data of random variables. Now we have defined a data frame. Now adding constant column for the intercept. The intercept is the value which will be intercepting our data. We can see we are adding add constant function which will be constant column to the x variable. Now we will be calculating VIF. The VIF stands for variance inflation factor. We are calculating multicollinearity using variance inflation factor. This is one of the method to calculate multicollinearity. Now VIF data equals to PD dot data frame. We have initialized now VIF dot data features equals to x dot columns. We are adding the constant columns of to the features and VI, VIF data UIF variance inflation factor x dot values comma I for I in range x in shape. It will be iteratively going back and forth to find constant data. Let's see. As we can see, there are the VIF is feature 1, feature 1 and feature 2, 3, and their VIF variance inflation factor is very near to each others. Hence, we have clustered or grouped the following features. Now let's take a look at principal component analysis. As included pandas and numpy library and sklearn modules. Now again we have taken a random sample data and defined our data frame. Now we will standardize the data. We have initiated a scalar object of standard from sklearn library. Now scale data equals to scalar dot fit transform. We will be transforming it into the more analyzable data. Now apply PCA. PCA as included in decomposition. We have created an variable PCA and PCA dot n components. The PCA is an object and we have initialized its constructor with components equals to 2. Now the principal components equals to PCA dot fit transform. We are transforming the scale data and storing it into the principal component. Now we will be creating a data frame with principal components PCA dash def underscore df pd dot data frame. We will be creating data frame where data equals to principal components, which we discussed is a scale data, and columns equals to principal component 1 and principal component 2. We have given two component. Okay, as we can see, it is very similar to multicollinearity, but in this, instead of feature we use principles. As we can see, these points are very near to each other. As the data set is very large or 100 of count, we can see it is giving us top 5 and last 5 results, and we can see that the values are very near to each other, but it is not as near. So that is it for today, guys. I hope you understand the multicollinearity and PCA, principal component analysis. Please rerun the code by yourself to understand the code flow and how the code works. Thank you.